In this video, we're going to learn how to properly multiply binomials. We're going to start with some vocabulary. One term is called a monomial, such as 8x. That piece on its own is a monomial. 7, now 7 is just a number. We don't usually call single numbers monomials, but technically they are. Negative 258m cubed, that's all one piece, that's one term. That means it's a monomial. 9x squared is one piece, it's called a monomial. If we had, for example, if it wasn't 9x squared, which means 9 times x squared, but if it were 9 plus x squared, that would not be monomial, that would be separating this term into two parts. So these are all monomials. Two terms, and they're usually inside a bracket, they're called binomials, such as 3x minus 7. So even if the brackets weren't there, 3x minus 7, 3x is term 1, subtract 7, term 2, that makes it a binomial. Same thing here, 14n cubed minus n squared, that's a binomial because there's two terms and they will always be separated by subtraction or an addition sign. That's how you know there's two of them. The distributive property, you learned it last year. It's what we call it when we're multiplying or expanding like this. So let's just talk about this piece for a second here. 2 times 4a minus 12. We're going to distribute the 2 into the bracket. We're going to distribute the 2 inside the bracket since it's touching the bracket. Let me just get a pen here. So I'm going to take this 2 and I'm going to distribute it in with multiplication. 2 times 4a, I'll just write it up here. 2 times 4a is 8a. And then 2 times negative 12 is negative 24. So we distributed the 2 into the bracket, and that's also called expanding. Grade 9 review, we're going to expand. Now expand means multiply it all out, like we did here. We expanded this. Label each part as a monomial or a binomial. Remember, when you're multiplying like terms, matching letters, you add the invisible exponents. I'll show you what I mean here. First one, a. So the m is in front of the bracket. I'm going to multiply m times 2m. So in front of this m, there's an invisible 1 here. I'm going to write it kind of an invisible 1. So that's really 1m times 2m. And we do numbers with numbers. So 1 times 2 is 2. And then m times m is m squared. And I'm going to get you to look up here again. We're adding the invisible exponents, or they are invisible in this case. This m has an invisible exponent of 1. Let me put it up there. This one has an invisible exponent of 1, and this m has an invisible exponent of 1, which gave us the exponent of 2m squared. Okay, continuing on, we also have to multiply that m that's in front with the next binomial, the piece of the binomial, which is a 1. M times 1, well, anything times 1 is itself, so that's just plus m. So these are not like terms here. 2m squared and m are not the same. We can't add them and get 3m squared or some kind of different term. They're not the same. Next one, b. In front of the brackets, I have a 2a, and first I have to multiply it by 6a. So we do the numbers first. 2 times 6, that's going to give me a 12. And now I do the a's. I have an a times an a squared. So this is where we add the exponents. So that the first a in the front has an invisible exponent of 1. So we have an invisible exponent of 1 plus 2. That gives me an exponent of 3. Now the next term, let me just change colors so it's easier to follow, is 2a times negative 4. And you can think of that as subtract 4, negative 4, minus 4, take away 4. You're going to get the same answer no matter what. Let me erase this stuff here. The first thing I want to do is multiply the number times the number with the sign. So that's 2 times a negative 4. That's going to give me a negative 8. And then here I have my a to the power of 1, and I have no a here. I have none. So it's just going to stay 8. That's not going to change. It's going to stay as an a to the power of 1. And again, those are not like terms, so I cannot put these two together and do 12 subtract 8. I can't do that. Part C. Negative 3x is in front of the bracket. It's one term. This is a monomial right here. And when we're done, we're going to label all these terms. So this monomial has to get multiplied into this binomial, both parts. First, negative 3x times 4x. So numbers times numbers. That means I want to take the negative 3 and multiply it by the 4. Negative 3 times 4 is negative 12. Now the letters. I have an x and an x. X times x, those have invisible exponents of 1 on them. So a 1 and a 1 give me x to the power of 2. Now I'm going to erase some of this and change colors so we can see the other one. Right here, I'm going to take the negative 3x multiplied by negative 5. Numbers times numbers. Negative 3, negative 5, positive 15. And I have an x here, but I have no x with the 5, so it's just going to stay a single x. And again, we can't take negative 12 and 15 and add them. They're unlike terms. So the other part of the instruction was, it said expand the following, which we did, and then label each part as a monomial or a binomial. So in front of each bracket, we had one term. That's a single m, that's a monomial. That 2a is a monomial, and that negative 3x is a monomial. So all of the terms that are in front are all monomials because there's no plus or minus signs with them. So this is a monomial. And the same thing for 2a. 2a is it goes together. It's one term. It's a monomial. And the negative 3x, it's kind of bigger, right? It's got a sign, a negative sign, and a constant, and a number, sorry, and a variable. But it's also a monomial because it's all attached. So right, monomial, it's all attached with multiplication. It's really negative 3 times x. Now the brackets, this bracket, the first bracket here, how many terms are there? There's one term here, two terms here, separated by the plus sign, so that's a binomial. Binomial. Next bracket, also two terms, it's a binomial. And this bracket as well is a binomial. They go together as a binomial. Instead of saying, well, why can't we just call that two monomials? Well, 4x is a monomial and 5 is a monomial, but the expression is telling you you're supposed to be subtracting them. 4x minus 5, you're supposed to subtract that 5 from 4x, whatever x is. So they go together, so they're a binomial. New for grade 10. So that was all grade 9 review back there. This is grade 10. Expand the following binomials and then simplify using the FOIL multiplication pattern. FOIL. So over here is the first one we're going to do. Instead of having a monomial in the front, which we had all in the last examples, this one's a binomial times a binomial. This method is known by its acronym FOIL, first, outside, inside, last, F.O.I.L. So I'm going to go over that with you. You don't have to remember FOIL. Some people like it as a handy way to remember how to multiply everything. So let's do the first terms. I'll color code it. So the first terms I'm going to do in this blue color. This is the first term in this bracket, and x is the first term in the second bracket. So I'm going to multiply these two together. The first times the first. That is x. Let me use black just to start here. 2x times x is 2x squared. Remember, we add the exponents. That's an invisible 1, and that's an invisible 1. So that's 2x squared. Now we go to the outside. We're spelling the word FOIL, so I'll do this one in purple. Outside terms. The outside terms are the ones that are on the very outsides of the brackets. They're like the bookends. So this right here, that is on the outside, and the 2x is also on the outside. Those are outside terms, are on the very far edges of our expression. So we have to multiply those together. 2x times 1. 2x times 1, that's pretty easy. That's just 2x. So notice what we've done so far is we have taken just this 2x, I'm ignoring the 3, just the 2x, I multiplied it by the x, and then I multiplied it by the 1. It's the same thing we did in the previous examples, except I have this that I haven't dealt with yet, but all I'm doing is I'm taking the 2x and I'm multiplying the 2x into both parts of this binomial. So I've taken care of that. Now I just have to do the same thing with the 3. I'm going to take the 3 and I'm going to multiply it into both. It's going to be multiplied by the x, and then I'm going to take the 3 times the 1. And over here, if we're going to use FOIL, the inside terms, the ones on the inside, that's these two. These two are on the inside. They're on the inside of the bracket. So I'm going to multiply those two together right now. Go back to my pen. So I'm doing 3 times x, and 3 times x is just 3x. All I can do is push them together, 3 times x, because there's nothing else to do. And then the last terms in my list here, I'll do those in green. The last ones are the ones that are last in each bracket. So the 3 is last and the 1 is last. I multiply those two together, I get plus 3. So that FOIL is a way to remember to get every combination of both binomials. It makes sure that you multiply the 2x by both pieces in here and the 3 by both pieces in here, but you don't have to remember FOIL. You don't have to remember that acronym. You can just multiply them all out to make sure you get them all. Usually what happens here is the 2 middle terms are like terms. They are in this case. So let's start with this 2x squared. There's no more x squareds. Like terms means the variable, the x, and its exponent, the 2, match exactly. I don't have any other x squareds here. So I have no like terms, so that's going to stay 2x squared. These two are like terms. If you have 2 x's in front of you and you get 3 more x's, you now have 5 x's. This constant, this 3, is just a plain number, an integer. It has no other numbers to add or subtract with, so it's just going to stay plus 3. So that's the end of the line for that question. Let's try another one. Again, this is a binomial. It's got 2 terms in it, and so is x plus 3, also a binomial. So we're multiplying binomials together, and we multiply the first term by both numbers over here, and then we multiply the second term by both numbers over here. And you can use FOIL to remember that, or you can just do it one step at a time and you won't forget. So let's just try it. I'm going to do the first ones together. So these two first, the x is being multiplied by the x. X times x is x squared. Now I have to multiply the x by the 3. These are the outside terms. X times 3 is 3x, and it's positive. Now I'm doing the inside terms. I'm going to multiply this 6. It has to get multiplied into both terms of that second set of brackets. So first I'm going to do 6 times x. That's 6x. And yes, we always put the number first and the letter second. And then the last ones are the 6 times the 3. 18. Any like terms here? Always make sure to look at especially the middle pair, and these two are like terms. If you have 3 x's and you get 6 more x's, you've got 9 x's. So that is an example where everything has been addition. I didn't give you any subtraction yet because it's just easier to add. But in our next examples, we do have subtraction. So if you like, now would be a good time to press pause and just try C on your own. Just see if you can do C on your own, and then press pause, take a few seconds, and then unpause it and come back and we'll do it. You can watch me do it here. So first, 3x times 4x is numbers times numbers, right? So that's a 12. X times x is x squared. Now 3x times negative 5, numbers times numbers, and this is a negative 5. So it's going to be negative 15 and then the single x. Now the inside terms, this is a negative 7 times 4. Negative 7 times 4, that's going to be minus 28x. And then negative 7 times negative 5, that'll be a positive 35. And our middle terms do match. They are like terms, so we're going to put them together. What is negative 15x minus 28x? Negative 43x plus, whoops, yeah, 35. So D is a little different. D says a square binomial. This power of 2, what a common mistake that students make is they think, okay, I'm just gonna like square this part and make it a 4x squared. I'm gonna square this number and make it a 9. That's not right. That's not what the power of 2 means. It doesn't mean, you cannot do that shortcut ever. The power of 2 means write it out twice. Even, I'm gonna do a little piece on the side here, even when you were in elementary school and you did, say 5 squared, that was really 5 times 5, which was 25. And because that's how you started doing work with the squared, you kind of thought, you kind of apply that anytime you see a power of 2 now, and you just square each piece. That is not what happens when we're with binomials though. Binomials are not monomials, as you know now. I can't just put the power of 2 on each term in the binomial. I have to write it out twice. So I'm going to start by doing that. The whole bracket gets written out twice. If you don't do that, you won't get any marks. Now I can go and do my expansion here. So 2x times 2x. So this binomial expansion or FOIL or distributing 2x times 2x. So numbers times numbers, 2 times 2 is 4, and then x times x is x squared. Now I multiply the next two parts here, the outside ones, 2x times negative 3, that's going to be a negative 6x. And now the inside ones. So this 2x has been multiplied by everything in the other bracket. Now I have to do the same thing for this 3, negative 3. So first, negative 3 times 2x is negative 6x. And next, negative 3 times negative 3 is positive 9. The middle terms match, so I write them as 4x squared minus 12x plus 9. Make sure when you see a power of 2, you do it that way, because whereas that question could be a 2 or 3 mark question, you'll get 0 if you just throw that power of 2 backwards into these things and just square them individually. You won't get any marks for that, so please don't do that. And here we are at our very last example for this topic. So now might be another time for you to practice. Press pause, do it yourself, and then come back and see if you're getting it right. Let's do x times 9x, that's first. That gives me 9x squared. And now I have to multiply that x to the other binomial piece, which is a negative 3. That's negative 3x. Okay, we're done with the x. We did all that. Now we're on to the 2. 2 times 9x is 18x. And 2 times negative 3 is negative 6. Do we have any like terms? Yes, the two middle terms are the same because they're both single x's, so I can collect those like terms and write it as 9x squared plus 15x minus 6. So this is an important concept on expanding binomials. You're going to do some practice questions yourself. Always check your answers because you could get them wrong over and over and over again, and you wouldn't even know if you didn't check the answers. And then you wouldn't understand why you don't get a good mark on an assessment, because you would say, but I did all my homework, but you did it all wrong. So please make sure to check the answers to make sure you're doing it right and you get every combination of multiplication piece that you need to do, and you're collecting like terms that you need to. And then that's it.